Hello, everybody. We'll get started in just a minute. All right. Thank you all for joining. My name is Will Lyons. I manage the product management team in the Oracle Enterprise Cloud Native Java organization. And I'm here with some of my colleagues to announce Coherence Community Edition and Helidon 2.0. We're very excited to make this announcement today. This is in the evening in the US. And to most of you, we expect our listening in the morning. First, I'll put up a safe harbor slide. This is a standard Oracle safe harbor statement. Most of the information we will be presenting today is about software that is available immediately, but there are some forward-looking statements that I will cover. Just some notes on today's program. We've got a large number of people and we've got a packed agenda, so we are not doing audio question and answers today. All attendee lines are muted. We do have a number of moderators in addition to our presenters today who can answer your questions using the Zoom Q&A. So if you have questions, please submit them in writing to the Zoom Q&A box, and somebody on our panel will attempt to answer that question for you. Please do not use chat. We prefer that you use the Q&A. We will be presenting today. You will get copies via email of the presentations we're making today, as well as a copy of the replay. And embedded in the slide presentations we will distribute are links to resources that you can follow up on. So let's get started with content. Today we are announcing in open source a new edition of the coherence technology provided in Oracle Coherence. So the core functionality provided in Oracle Coherence is now available in Coherence Community Edition. We are also announcing a new release of Helidon. Helidon is a set of libraries available in open source for developing Java microservices. And today we're announcing general availability of Helidon 2.0. Both of these technologies are extremely relevant for developing new Java microservices. They're both available in open source, so we're providing transparent access to the developer community of the new functionality we're delivering in these releases. They both deliver innovation. Helidon is offering new support for in microprofile for supporting GraalVM native image. We're supporting new microprofile features, and we're supporting new reactive programming capabilities in Helidon SE, so there's lots of new features there. We're also including in Coherence Community Edition all of the technologies available in the recently released Coherence 14.1.1 version, as well as new features that are being made in open source and Community Edition itself. So there's lots of innovative capabilities in these releases, and both can be used in polyglot architectures, and you'll be hearing more about that during the course of these talks. I'll introduce briefly today's speakers. We're going to start with Randy Stafford, who's product manager for Oracle Coherence to cover Coherence Community Edition. We'll follow Randy with Joe DePaul, who's a development manager in the Helidon team, and will cover the new features available in Helidon 2.0. We'll follow that with Alex Seovic. Alex is an architect and a project lead in Coherence, and he will be reviewing a new demonstration application that shows how Coherence Community Edition and Helidon 2.0 can be used together. And we'll finish up with Dave Cabellis, who will present some forward-looking information on Project Verrazano, a new project that we've been talking about for the last several months, and that will be delivering in open source soon. So with that, I'm going to turn over the floor to Randy to share the exciting news about Coherence Community Edition. Randy?
Thank you, Will. Can you see my screen and hear me okay?
Yes, we can.
Yes, we can.
Thank you. Okay. Hello, everyone. Thank you for joining this release announcement webinar. I am Randy Stafford, the product manager for Coherence at Oracle, and we're very excited to share this news with you about Community Edition of Coherence. I am going to assume that some people attending today are already familiar with Coherence, and many attendees may not be familiar with Coherence. So I'm going to start with a bit of introduction to Coherence for those who are not familiar before getting into the specifics of Community Edition that will be of particular interest to friends of Coherence already. So with that, I'll get started. A very high-level introduction to Coherence, what it is. Coherence is the world's first and leading in-memory data grid technology. It has been scaling mission-critical systems since 2001. It is, in one phrase, clustered data management and grid computing software. And historically, to date, we find users of Coherence tend to deploy it as shown here. There is a tier of architecture that we call the grid tier, which tends to sit between enterprise systems, mainframes, databases, packaged applications, and applications or services, including microservices that are serving interfaces to a wide variety and a high volume of clients, browsers, mobile apps, any kind of clients. So this grid tier is where Coherence lives. And now I would like to go into a little bit more depth on what I mean by clustered data management and grid computing software. So to begin with, Coherence implements clustering. It clusters Java virtual machines together. So if you launch a Java virtual machine with the Coherence jar, the first one you launch will attempt to find an existing cluster. If it doesn't find one, it will create one. The second and nth one you launch will announce itself to any existing cluster. An existing cluster member will recognize the announcement and welcome that new JVM into the cluster, at which point it has joined. The next concept in the data management is what we call partitioned data storage. So each member of a Coherence cluster runs a set of services. One of them is a partitioned service that is responsible for managing partitions of data maps that Coherence is storing. So when a member starts, it asks for a fair share of partitions and receives them. And then backups are created of those partitions in other JVMs that are members of the cluster. So by default, we keep a backup of every partition. And this pattern scales out to literally hundreds of member JVMs. We have customers that run Coherence clusters of over 500 JVMs. These clusters can span machines, they can span racks, they can even span sites. And the data storage capacity that is afforded by a Coherence cluster scales into the single-digit terabytes. That's how much data we can manage in memory of Java virtual machines. So when you want to put something into a map in Coherence, we have obviously a key value data model. So your application code is interacting with a map interface, and we can put any serializable object graph, which is a little bit of a distinction between some of the other products out there. So when you call map put with, in this case, an identifier and a person, we will convert the key and the value to binary, and we will compute a hash function on the key and take the modulus of the number of partitions to determine which partition that key value pair should go into. And when we do that, we create a backup copy of the key value pair in a different member. One detail here is that we look up in a table which member currently owns the partition, and that table is updated anytime cluster membership changes. We also have optional disk persistence for the data, which makes the data recoverable after the cluster has ended. And if you want to recover the data in a new cluster, you can, which allows Coherence to be used as a store of record. So finally, control returns to the application after all of that has happened. And this automatic data partitioning, we call it, is also a differentiating feature of Coherence. The application doesn't know about the data location, and this gives us constant latency regardless of the data volume and the transaction volume. So a typical write takes about 1 millisecond. A typical read takes about a half a millisecond from a remote cluster member. So the next concept I want to talk about is fault tolerance. We have several fault tolerance, we have several death detection mechanisms that allow us to tolerate failures of processes and machines. We have a TCP mesh between processes. We have IP-based monitoring to know if a machine has died. So if an application is putting a key value pair into a map in Coherence, by default, we keep the backup on a different machine. And if a machine should die, there are a number of things that happen. We detect the death of that machine. We reestablish the TCP mesh between the remaining members. We promote backup copies to primary, and we create new backup copies so that we're back to the safe state we were in before the failure, and then any transactions that are happening against Coherence at that time resume after that rebalancing. The next data management concept is distributed queries. Coherence has a query subsystem, so this code is attempting to retrieve all of the cars that are red. So give me the set of entries where the car color is red. These queries are sent to all cluster members hosting primary partitions of data, and we can use index data structures for greater efficiency to basically avoid the equivalent of a full table scan in Coherence. And the query logic is tolerant of member failure while it's happening. We also have aggregation. So this code is attempting to count the number of red cars. And this is basically a MapReduce algorithm whereby the query and the aggregation is sent to all JVMs hosting primary partitions. Each one filters its local objects, that's the map step, and returns the number that passed the filter. And then in a second step, this is the reduce step, each member's red cars are aggregated into the total, which is sent back to the client. And switching to grid computing features now, we have a feature we call in-place processing in Coherence, whereby in this code, we want to set the price of a car that we're storing. So with in-place processing, we send the logic to the data and not vice versa, which co-location of processing and data is a pattern that allows for very high performance and very high throughput, very high scalability of systems. We can do this with lambdas in Java 8, and we can also do it with our own entry processor classes. And while the entry processor or lambda is executing on the member owning the primary partition, it has exclusive access. So this is essentially lockless concurrency control. Changes that are made to that partition are backed up. We guarantee idempotency of this execution, and we have a unique feature called partition local transactions, whereby one invocation like this can modify multiple entries in one transaction as long as they're in the same partition, which is a differentiating feature for us. So after the partition changes are backed up, we return control to the client. And finally, we have a very rich event model that forms part of our grid computing features. Applications can register listeners on map events. We also have very rich server-side eventing. So in general, if we have a lot of application clients that are invoking or basically modifying data in Coherence, we can generate server-side events to React, and we can also send events to the client, which are queued, and the client can react accordingly. These events are sent to the client asynchronously with an at most once delivery guarantee, and that delivery is as resilient as other parts of Coherence. So that's a little bit of introduction to the features. I'd like to next talk about what Coherence can do for enterprise applications. These are proven use cases of Coherence that hundreds of organizations around the world have been implementing for nearly 2 decades now. The motive is always the same. These organizations want to improve the performance, scalability, reliability, and availability of their systems and reduce the cost of their systems. So the first and most typical use case is basically providing very fast access to large sets of data and offloading back-end systems of record at very high scale. It's commonly the case that enterprises will have applications or databases which are exposed to new channels, mobile applications, web channels, and they can't handle the load. So Coherence is injected in front of those enterprise data sources to offload them and provide fast access to data. Next one is a grid computing platform for analytics. This is very popular in the financial services industry. A number of our financial services customers run risk analytics calculation in the grid using that in-place processing functionality that I went over a minute ago. A third one is event-driven architecture, whereby Coherence is used as a temporary cache of events that are coming in from some stream, and logic is run over those events to process them and produce other events that are sent out. And then finally, a relatively newer use case, but still very proven, as you'll see in a minute from a testimonial, is using Coherence as a system of record for very high-scale microservices architectures. So you may have heard of other in-memory data grid products. Why should you use Coherence? First, Coherence has proven reliability at very high scale. It's powering hundreds of high-scale mission-critical applications across industries around the world that you may even use without even knowing it. Coherence has a track record of innovation from creating the in-memory data grid space to leading it all along. It has been copied but never fully duplicated. It forms a powerful foundation for polyglot microservices applications, and it is now available free and open source, and it has the property that developers really like of elegant simplicity. Coherence is really a joy to use. And now I'd like to play a short video from one of our customers, Arun Giri at Union Pacific Railroad, who has built a fantastic microservices architecture on Coherence. So here's the video. And Arun, could you please introduce yourself and your role at Union Pacific Railroad?
Well, thank you for having me, Randy. So my name is Arun Giri. I am an Associate Vice President and Lead Engineer for IT at Union Pacific Railroad.
Can you tell us a bit about the high-scale microservices system you're running on Coherence at Union Pacific?
The product I just mentioned that I'm leading the architecture team for, it's called Net Control. That's our next generation logistics platform, which we're been building. So it's a massively distributed system. We have about 5,600 APIs in production right now. Just to give you an idea of the scale of the system, right now, even though we're not fully live, we're about 1.3 billion API calls a day is what we're serving on this platform. And we're producing around 280 to 300 million events.
How much data are you managing, if you can say?
Somewhere close to 9 terabytes is what I have in Coherence caches. So if you think about any microservices implementation, it's largely stateless, and stateless systems are extremely data hungry, and state management is one of the biggest challenges we face. And this is where Oracle's Coherence product played a huge role. 10,000 API calls per second is what our data layer had to serve out. One of the optimizations we had to do was to serve out a cache domain model to our app layers. And we didn't want to embed that state in every JVM. Like we have around 20,000 JVMs in production. That's our stateless app layer. And when we finally landed on Coherence, that has been serving out. That is our state management layer for this logistics platform today. And that's where all our data is stored.
Can you say what your experience has been in production?
Okay, so I'm going to jinx this by saying that I haven't had a major crash. So, all right, let's do that. So you should not have asked me this question. It's been a great experience. Like so far, we haven't had any major crashes.
What is your reaction to Oracle launching the open source Coherence Community Edition?
That's the most exciting news we've had since like some of those released. Like Randy, the joking aside, I think that is going to make a huge difference for customers like us. Open sourcing helps customers like us who have such a large footprint and we've depended on Oracle's Coherence to be there for us. To say that, okay, now there's a bigger community. And so it's a huge win.
The logistics system that you're replacing had a lifespan of over 40 years. What is your expectation of the lifespan of your microservices architecture?
Well, I keep joking with my management, which says like, if it lasts 20 years, I'm good because I won't be here. So I have no doubt that this will last just as long or longer.
Excellent. Well, thank you very much, Arun, for the partnership and for the conversation here today.
All right, thank you, Randy. Thank you. And thank you for all the help you guys have given us over the years. And it's been a great partnership.
Okay, so fantastic story at Union Pacific, an iconic 160-year-old American company with really innovative technology and a very massive microservices architecture that is literally running the railroad there. So moving on, here is Coherence Community Edition. It is an open source project hosted on GitHub. And at the end of the talk today, Will Lyons will have a slide with all these links. So github.io/coherence is where the source lives. We have a README file with sort of basic outline here, how to get started and so on, how to get it. And then we also have a full documentation site that I'll show in a minute. This is on Maven Central. Here's all our artifacts that are out there. And we have Docker images with Coherence Community Edition on Docker Hub. And then finally, here is the Coherence Community Edition website with a lot of helpful animations, code examples, links to documentation, and so on. So these are the assets that we're launching. And just a little bit of description about what Community Edition is. It is a free and open source edition of Oracle Coherence. It's hosted on GitHub under the Universal Permissive License. That is the license that we've chosen. And the artifacts from Community Edition are published in Maven Central, and Docker images are published to Docker Hub. Coherence Community Edition entitles a subset of our commercial product features, and I'll show the detail of that in a minute, but that subset is everything that you would need to write a modern cloud microservices application. So this is a new option for new projects, projects that know they need fast, scalable data access. We'd really like to have them look at Coherence Community Edition. And this is also part of a platform for cloud-native microservices applications, as Will introduced, and you'll see more of in the rest of the talk today. So in terms of the features that are entitled, it's almost everything in our commercial editions. A couple of things that are left in Enterprise Edition are the managed coherence servers that's using WebLogic to manage coherence, and Coherence Web that uses coherence to manage HTTP session state. Those things remain in Enterprise Edition. And then, of course, we have a handful of very high-end features that are in our commercial Grid Edition. So in terms of the release numbers and the support lifecycle of the releases, we will continue to have what I'm calling Oracle numbered releases of Coherence Community Edition. For example, 14.1.1. Those will be made according to Oracle's schedule, and they'll be supported according to Oracle's lifetime support policy. We will also have interim releases of Coherence Community Edition that are numbered with a month pattern. So for example, 20.06, we'll make those every 6 months containing features in development, and they'll be supported until the next release at minimum. And our reason for doing this is we want to get features to market faster, get them into users' hands faster. And this is a pattern that's been adopted by Java, Helidon, Ubuntu, etc. Features from these interim releases will be rolled into the next Oracle numbered release as appropriate. Not necessarily a tiny patch release, but the next appropriate Oracle numbered release. The Community Edition launch that we're announcing today includes 2 releases, 14.11.01 and 20.06, and I'll talk about what's in those in a minute. And in terms of getting support for Community Edition, all Community Edition users have access to the tools on our GitHub page, the issue tracker, the wiki. They also have access to our public Slack channels. And then customers of Oracle Coherence support also have access to my Oracle support to raise issues on Community Edition. So here's what's in the releases. Community Edition 14.11.01, of course, includes all of the core coherence features that you saw in that matrix, and all the new features that just went into 14.11 that was released a couple months ago. Some big new features there, including a messaging implementation, distributed tracing support, etc. And then in 20.06, we are releasing a new gRPC proxy server, so we can have native language clients talk to coherence clusters over gRPC. So we're releasing a Java client that's talking over gRPC now, and we're releasing support for container dependency injection and Helidon microprofile, which you'll see in great detail later today. So finally, this is one component of a new platform for cloud-native microservices. The other components being Helidon, Graal VM, and Verrazano, most of which you'll hear about today. And with that, I'd like to say thank you very much, and I will turn it over to the next speaker, who is Joe DePaul. Thank you.
All right, thank you, Randy. All right, hello, everybody. I'm going to give a presentation here on Helidon 2.0. I'll start with an introduction of Helidon. As Will said, Helidon is a set of Java libraries for developing microservices. That's pretty straightforward. We're an open source project hosted on GitHub. And here you'll see the URL. We encourage you all to come visit us and give us a star. We're also available under the Apache 2 license. So in terms of Java frameworks for developing microservices, you know, there's a number of players out there. And this diagram is by no means scientific, but we just try to give a feel for the lay of the landscape in terms of other Java microservices out there. So down at the bottom, you have smaller micro frameworks. These usually have a smaller surface area. They're kind of easy to learn, fun to develop in, fairly compact and fast. Then up at the top, you have larger full stack frameworks. Spring is the classic example of that, which has a very large, somewhat complicated surface area and set of intertwined dependencies when you go with that route. So where does Helidon fit? So Helidon, we actually have 2 editions. We have 2 flavors, we call them. In the micro frameworks area, we have Helidon SE, which is a lean, reactive, no magic style, lightweight framework. Built on top of that, we have our microprofile support, Helidon MP. And so that lives a little higher up on the stack here with the other microprofile based implementations. So as I said, Helidon SE, it's a small, fast framework focused on a reactive, non-blocking set of APIs, a very small footprint. Your programming style will be functional. You use builders and Fluent APIs to operate on POJOs. We like to say it's very transparent with no magic. So very simple, lean, and fast. With Helidon MP, as I mentioned, it supports microprofile. And what microprofile is, this is a working group that was started a number of years ago to standardize a set of Java APIs for writing microservices. So it consists of a collection of Java EE or Jakarta EE APIs, and then it extended that with its own set of microprofile APIs. But they all follow the same Java EE style of programming. So you're programming with annotations using dependency injection. So anyone who is familiar with Java EE or Jakarta EE and is used to developing with those APIs, then Helidon MP would be a very good fit for that. Also, since it is somewhat standardized APIs, there is multi-vendor support for microprofile, which is another benefit of going that route. As Randy said, Helidon, along with Coherence CE, they're part of Oracle's cloud native stack. So you see that here. I won't go into much detail here. You'll hear a little bit about that at the end of today's webinar. Okay, so now I'm going to dive a little more into Helidon features. So with Helidon SE, we have all the capability you would expect from a cloud native framework and the things you need to write cloud native applications. So we of course have our reactive web server, which provides the REST framework for writing your REST endpoints and business logic. We have the things you would expect like config and tracing, health checks, metrics, security. We have support for gRPC, both on the server side and client support. And then some things that are new in 2.0 is we've added a database client and a web client. And I'll have a few more details on those later. We've also added reactive support, reactive streams and messaging, and then cross-origin resource sharing support and WebSocket support. So a couple of these new features, you'll notice they're tagged with a little red triangle. That indicates that these are kind of new early access features, and the APIs may be subject to change, although we certainly don't expect making changes to the APIs, but that could happen. For Helidon MP, again, we have the standard set of microprofile APIs. Those are in blue. And you see what you would expect there in terms of health check and metrics, etc. The purple boxes are the Java EE or Jakarta EE components. And so we have JAX-RS for the RESTful web services, JSON processing and binding, CDI, and JPA and JTA. So obviously, if you're familiar with those APIs, we provide those in Helidon MP. New to Helidon in 2.0 are the microprofile reactive components, the reactive stream operators and reactive messaging. We've also added support in MP for Jakarta WebSockets, as well as the CORS support for cross-origin resource sharing. In addition to those components, right, the library components, we've worked on our build and tooling around Helidon. So when you build your application, you have a couple choices for what you want your final packaging and application runtime to be. So we of course support a standard executable jar file. In this case, it's a thin jar where the dependencies are kept outside of the jar. This makes it very Docker friendly. So we've had that also obviously in Helidon 1.0. We also support now GraalVM native image support. So native image is the ability to take your Java application and compile it to a native binary, a native executable. This gives you a smaller memory footprint as well as very, very fast startup time. We had that support previously in Helidon 1.0, and I mean for Helidon SE. And in 2.0, we're adding support for that for Helidon MP, for our microprofile support. We're also adding support for JLink custom runtime images. So this is new in 2.0. This leverages the JLink tooling available in the JDK. And this lets you generate a custom Java runtime for your application. And so after running and building with our JLink tooling, you end up with a self-contained application that includes your application code, your runtime dependencies, as well as a customized JRE that has just the parts of the JRE that your application needs. In 2.0, we're also adding the Helidon CLI. This is an ease of use tool that lets you easily create Helidon projects based off of templates. Plus, we support an incremental build and relaunch loop that lets you quickly be able to make changes to your application, and it will automatically recompile and restart for you. This packaging I mentioned, this is available through what we call build profiles, and you create your project, and then at your build time, you can choose which of these packaging formats you want to use. So I kind of went over these already. With the JLink image, we also support generating what's called a CDS archive. That's class data sharing archive. And this is an archive, a file that contains pre-processed class files that can more quickly be loaded by the JVM. So it also helps to improve your application startup time. So here we have a little comparison of these different packaging formats. So on the left graph, we're looking at Docker image size, and don't focus too much on the absolute numbers. I'm not sure what base image was used to build these, but you can see that, you know, the traditional jar, that includes your Docker base image and your full JRE and your application. When you use JLink, your image size shrinks because you now have a customized JRE. You only have the parts of the JRE you need. In this example, I think these measurements were made with the CDS archive included. So if you choose not to generate the CDS archive, then the JLink image size would be tens of megabytes smaller than this. And then finally, on the right, that bar is the native image, which is smaller still. On the graph on the right, we have startup times. So you see a pretty good startup time with just the jar file. That improves with the JLink image. And then finally, as you can see with native image, the startup time is instantaneous. So the goal here is we provide options because there's different trade-offs that you can make when choosing which type of end application packaging you want. If you really want fast startup time, then native image works well for that. But there's some trade-offs in terms of limitations around maybe language features you can use, right? Native image does not work with all third-party libraries or all language features. So in that case, you could choose one of the, either the JLink image or the standard executable jar. I mentioned the CLI. This is just a shot of the help screen. As I said, you can use it to initialize and create your initial Helidon application. It's very simple to do that. And then we have what's called the dev loop, which you just run Helidon dev, and then we monitor your project. And every time you change the source file, we recompile and relaunch your application so that it's very easy to do the iterative development on your desktop. I mentioned with Helidon SE a couple of new components that I'll just touch on quickly here. So these are significant new components in 2.0. We have the DB client. This provides a reactive non-blocking database client. It works with both relational and non-relational databases. It also works with existing blocking JDBC drivers. It supports all of Helidon's observability features in terms of metrics and tracing. And it integrates overall well with the Helidon SE API. The Helidon web client, it's a non-blocking reactive HTTP client. Again, it's designed to integrate well with the Helidon SE APIs so that when you're dealing in a Helidon SE server handler and an endpoint, the server request and response is very consistent with the client request and response. And the media support you use for handling different media types, that is common between the server API and the web client API. So completely integrated, again, with the full observability features of Helidon. I mentioned the reactive stream support. We have this both in SE and in MP, where we implement the microprofile specifications. We want to thank David Karnock, who did our reactive streams implementation. You know that he is the person behind RxJava. So we feel very fortunate to have him contributing our reactive streams implementation. And we see that in the performance of our implementation. So this just shows you some benchmark comparisons between the Helidon reactive stream operators and an implementation from SmallRye, which is another microprofile implementation. So in this case, the longer bars are better. You see that we have a significant performance advantage with the Helidon implementation. A CORS support, this is cross-origin resource sharing. Typically a browser, when it loads an application and that from an origin, and that application wants to access resources, the browser will typically restrict that to the same origin that the application came from. CORS is a mechanism where the application can basically state what is safe to allow in terms of cross-origin resource sharing. So we have this support both in SE and in MP. It's also supported by our built-in services as well for health and metrics, etc. So a simple feature, but one that's very important to implementing a microservice. So as I said, Helidon is open source. I kind of gave a very quick overview of some of our new features. It is a supported product as well from Oracle. So if you are an existing Oracle customer and you have one of the products here that I show on the screen through Oracle WebLogic Server or the Coherence Enterprise or Grid Edition, then you are entitled to support for Helidon, and you get that right now, today. So if you need to access support, file support tickets, you can do that through My Oracle Support. And you'll find a Helidon entry has now been added for WebLogic and Coherence under product usage and application development. Of course, we're an open source project. We're an open source community. We love working with our community. We're very responsive. So you always have that option as well. In fact, we kind of encourage that at first. If you have an issue or a bug or any questions, please, you can come through one of our many community channels. And we're pretty responsive with that. Kind of your call to action. I know this was a very fast overview. If you're not familiar with Helidon, please go to helidon.io and click on Getting Started. And you can have your first Helidon microservice up and running in just a minute or two. I also have here URLs for our blogs on Medium, our YouTube channel, and then of course our GitHub repository. So I really encourage you to come check us out and try out Helidon. So up next is Alex. He's going to with a sock shop demo. This demo is written using Helidon and Coherence, and I'm happy to turn it over to Alex now.
Thank you, Joe. Okay, so as Joe said, this demo shows Coherence and Helidon working together to implement an application that was originally written by WeWorks and published under Apache license as a canonical example of microservices application, kind of similar to PetStore, what PetStore was for Java EE, but for microservices. So it has a number of, if you look at the architecture, it has a front end and 6 services: carts, orders, users, catalog, payment, and shipping that interact with one another. Orders, as you can see from the diagram, is kind of the key service in the mix because it talks to many other services. So from the implementation perspective, the original SockShop implementation used Node and Express for a front-end implementation, and then it used different technologies, various technologies, because that was one of the things they wanted to show for both service implementation and for service backends. So, for example, cart service was written using Spring Boot, and it used MongoDB as a backend. Orders was done the same way. Users was written in Go using MongoDB, catalog in Go using MySQL, and then shipping used Spring Boot and RabbitMQ for persistence. So the problem with that is, I mean, well, it is a good example, and it shows that you can use, really, when you're building microservices, you can use many different technologies and put them together in many different ways. From operational perspective, you have to think about how easy it is to scale each of these services, right? You need to be able to scale not only the stateless services that we see in this diagram, which are fairly easy to scale, right? But you also need to scale their backends. And those are much harder to both provision in a fault-tolerant fashion and to scale. And then the other question you need to ask is how easy it is to monitor them, right? Because you need to know that everything is working, that everything is in a state it should be in. And each of these technologies requires a different monitoring setup, right? You need to configure different Prometheus. Well, you need to have Prometheus, you need to publish metrics. Some of them can publish to Prometheus, some of them can. You may need to use many different monitoring systems to pull the information together and show it in some kind of a dashboard, right? So all of that needs to be considered. So what we did in SockShop, in Helidon and Coherence version of SockShop, is simplify the architecture quite a bit. So instead of having stateless services that use different backend stores, we basically embedded Coherence into the service itself. So Coherence is used to provide service implementation, to provide the APIs, and Coherence is used to store the data. So that way we have a single container, for example, that can both store the data and process incoming API requests. And we kept the original front end the way it was. So we're actually using, in a demo that you'll see in a minute, we are using the same front end that was in the original application, actually running the same Docker container from the original application and just hitting our service implementation. So let's look at the demo quickly before we go into some other more interesting aspects. So this is the front page of the demo, and you can do things like browse catalog, you can add products to shopping cart, right? And then once you are happy with what you have in your shopping cart, you can proceed to checkout. And this will create the order. And then you can also view your submitted orders. So it's fairly simple, but kind of common, easy to understand e-commerce application. So all of these things are now, front end is kind of tying everything together, talking to all different services on the back end. So now that we've submitted the order, let's go back here and talk about how is this better, right? So what is different in these services? Well, we don't have the same issues that we had with the previous setup, right? These services should be much easier to scale, should be much easier to monitor. And then we can look at implementation if we have enough time, but the implementation will be simpler as well. So let's look at some of these things. So right now, I have this running in a Kubernetes cluster, and I actually have only one pod for each service. Again, these pods are stateful. They store the data using Coherence, and they process incoming HTTP and gRPC requests using Helidon. So I only need one pod. I don't need pod for a data store and pod for the application. And because I have only one, if I look at some of my monitoring metrics, I will see that I have 6 cluster members for 6 different services. with 12 endangered services. So what does that mean? Because we only have one member for each service. If I look on the services screen, I will see that my cart service is in danger because it only has one member, catalog service is in danger, et cetera, et cetera. If you remember from Randy's talk early on, Coherence creates backup copies on a different cluster member because we only have one member for each service. There is no there are no nodes to create backups on. So let's fix that. So I'm going to run a command that will basically do Kubernetes kubectl scale coherence for each service and scale to 3 replicas. So as you can see, it's printing out as each service is scaled. And when we look at the pods, we should see that they're starting up now and that we have 3 pods for each service. Right, and it will take a minute or two for them to start. In the meantime, we can look at some of the other dashboards here. So we also, one of the things that Helidon gives you is the ability to easily export application metrics. So we exported some metrics that are related to orders and payments, etc. And we created Grafana dashboards for them, the dashboard for them. So you can see like the number of processed orders and the order processing time. We lost it because it was 5 minutes ago, but et cetera, et cetera. So let's see what's happening here. So the cluster is scaling up. We have 16 cluster members now. 14, we are losing some. And services, if we look at the service, it's still kind of rebalancing everything. But if you look at the services, we see that now we have 3 members for a catalog service, 3 members for the order service, et cetera, et cetera. So the cluster is now in a site safe mode. And what that means is that we basically have 3 members for each service, and they are all in different data centers. So we could lose a single data center and still have all the data preserved. And if we look at the caches, you can also see that we have, we have one order in our orders cache. We have different number of objects, and you can see the size of the data in each one of them. And finally, we can see that we reached 18 cluster members. So that part is easy. I mean, anybody can scale to 3 cluster members. And if we look at this, we should see that we have all the nodes in ready state. But let's do something more fun. So let's scale order service because we expect a lot of orders. Oh. Let's scale orders to 100. And we did scale it. Now this will take some time. If we look at Kubernetes, we'll see that we now have 100 orders pods, but it will take some time for that to initialize. So let's look at some of the other things that Helidon and Coherence together provide from a monitoring perspective. So one of the things that we have as part of the integration is actually seamless tracing all the way from Helidon through Coherence, from the service API all the way down into the data tier. So for example, if we look at trace for the order processing request that came for a new order, we can see that order service makes a request to cart service, for example, to get items from the cart. It makes multiple requests to user service to get information about customer, credit card, and address. And then it calls Coherence. So it calls process order on the order processor, which then saves the order in a Coherence order repository. And then on the Coherence end, you can see it. So all of this tracing up to this point came from Helidon. But then in Coherence, you can see that we are making put requests from the client, and you can actually see which client is making that put request. We're doing it on member 8. And that put request is then going to and being processed on member 7. And then a backup for that request is processed on member 2, coming from member 7. So this is basically the full path from saving the order object in Coherence on the application 1 node. The order has went to another node to be stored, and then to another node to be backed up. So this actually involved three cluster members to get this order processed. And then we can look at another trace which shows call to get sock count for our product browser. So in this case, we can see that Helidon is making call to Coherence catalog repository get sock count, and then that is using Coherence aggregation. So in this case, we had 3 nodes, 3 members in the order service, just like we had before, or actually in a catalog service, which is what we have now. And this aggregate request was executed in parallel across these 3 members, and the result was returned to the client. So that's an example of how you can monitor things across many nodes and see what's actually happening throughout Coherence cluster when you're executing traces from when you're tracing information from Helidon. So all the way from get request to the catalog size endpoint down to Coherence aggregate request, you can see how long each part of the operation took. So going back to this, let's look at the implementation. So some of the main integration points between Coherence and Helidon is that Helidon actually bootstraps Coherence via CDI. So if you simply need to put Coherence CDI server jar in the class path, and it will be started, Coherence will be started automatically inside of Helidon process. You could also use CDI throughout application, both to inject Coherence resources into the application and to use CDI observers, et cetera, et cetera. Metrics are automatically integrated with Helidon as well. So all the metrics that you saw in Grafana, they're actually being served by Helidon to Prometheus, which collects them, and then we display them in Grafana. We can also use Helidon configuration to configure Coherence, and we can use Coherence as a configuration source for the application. And then finally, we have tracing, which is just saw the example of. So from the implementation perspective, I mean, for the most part, you're building your typical JAX-RS applications, but there are a couple of features that I do want to point out. When you're using Coherence, you're effectively working with the API that is similar to a Java util map. So we have a named map interface that you define. You can do puts, you can do other things. And in this example, we're doing what Randy was showing earlier, which is basically in-place processing. So we are sending a Lambda into the cluster to invoke logic on a cart to add a new item to the cart. So instead of getting the cart from the grid, changing it and putting it back, we can actually send the item to wherever the cart lives. You know, we're gonna have 100 and some node cluster in a minute. And this cart could be anywhere, right? Anywhere where cart service is. So this entry processor will go wherever this cart ID, wherever this cart belongs, it will add the item to the cart and update the cart, right? So that's the way to do concurrent distributed programming in a much easier and much more performant way. The other thing we have is rich event model based on CDI observers. So in this case, we are using Coherence server-side events to process order. Whenever order status changes, we do some additional processing. So initially, when order is stored in Coherence, it has status of created. So when we see that order was inserted with the status of created, we execute a logic to process payment. That could put the order in either paid or payment failed state. So if the payment is processed successfully and the order changes to paid state, then we can ship the order, et cetera, et cetera. By default, we do nothing because we're in terminal state. So this allows you to easily implement event-driven handling of different application aspects. And then last but not least, we have implemented in Helidon for something similar to JAX-RS for gRPC. So it's just as easy to build gRPC services as it is to build HTTP services. So you can basically define a service interface mark methods with annotations such as unary, server streaming, bidirectional, but depending on what type of gRPC method you want to implement. specify marshal to use, so you're not tied to protobuf as you are when you're generating gRPC by default. So it provides a much nicer, much cleaner way to implement gRPC services. And then on the client side, it's kind of similar to what you do with JAX-RS REST clients. You define a service interface, you specify which service it points to, which marshaller to use, which channel to use to connect to the server. And then again, put annotations on the methods and inject gRPC proxy into a field whenever you want to use it. So that's it. And let's see what happened here. If we are lucky and the demo gods are with us. We should have a bunch of cluster members. Well, they're not completely with us. We got almost there. I don't think there are enough resources in this Kubernetes cluster to get all the way. But, well, actually we did. Maybe it just needs updating. So you can see that order service is now at 100 members. There are no endangered partitions, no vulnerable partitions. We are site safe. If we look here, we should see all the pods running. Yep. Yeah, so it's actually looking good. So I think that's all I had. Thank you very much. And I will hand it off to Dave Cabellos to give you a few, to give you some information on Verrazano. Thank you.
Thanks, Alex. And I realize we're actually running a couple minutes behind here. If you've got 5 minutes, I'm going to go through this very quickly. Just want to talk about some new things that we're doing here. You've heard Will, Randy, Joe, and Alex mention this mysterious Verrazano a couple of times. I'm here to fill you in on what Verrazano is, and again, all in about 5 minutes, maybe less. So, you know, I think we all acknowledge that container adoption continues to increase. And with that adoption comes, you know, additional challenges, you know, especially thinking about microservices, lots of things to manage, lots of interactions and connections to manage, lots of environmental challenges. Kubernetes kind of takes us, you know, a good chunk of the way, but it doesn't really, Kubernetes alone isn't enough. Oracle's been investing in a number of technologies over the last couple of years that help companies along this, you know, digital transformation journey, including things like technologies we talked about today, Coherence and Helidon, as well as investments in Graal VM, the Oracle Linux cloud native environment with its collection of CNCF components, Oracle Container Engine for Kubernetes, and of course, WebLogic Kubernetes Toolkit. All of these things kind of come together, you know, and then it's like the question is, where are we going? And that's where Verrazano Enterprise Container Platform comes in. Verrazano, you know, leverages and builds on these technologies, as well as, you know, curates a set of open source technologies. Verrazano provides workloads management across clusters and environments. It provides an integrated pre-wired monitoring stack, again, for collections of applications, as well as your the infrastructure where the applications are running. You know, this is built, designed to work as part of CI/CD systems. You know, DevOps and GitOps are baked into design, and security is also, you know, part of the base design of Verrazano. So it's, you know, meant to be secure out of the box, you know, with security best practices. And then, you know, to top it off, we've got multi-cluster management, multi-cluster infrastructure management as part of this overarching package. This is, you know, Verrazano Enterprise Container Platform. And as I mentioned, it is a collection of some open source technologies. These, you know, typically these are technologies that you're already trusting, like, you know, Istio, Prometheus, Grafana, Elasticsearch, you know, Rancher, Alert Manager, et cetera. So these all form part of that platform, and it's a curated stack that comes from Oracle. We build it in-house. We scan the images and test, make sure everything works well together. It is meant to be a platform for modernizing your traditional applications, as well as hosting Java microservices. We've seen, you know, quite a bit of that today, as well as polyglot microservices. And all of this runs across, you know, multiple Kubernetes clusters, and those Kubernetes clusters can be in different locations, including public cloud, can be Oracle Cloud, other cloud vendors, private cloud, again, spread across multiples of these. So let me just peel back the curtain just a little bit to take a deeper look technically, again, trying to keep this moving. So the notion of, so Verrazano includes this notion of an application model, right? So think of a YAML file that includes a list of your application components that you want to manage together. So think in terms of, I've got maybe a set of microservices and maybe some traditional applications that have some level of dependency on each other, or maybe even a very distinct dependency on each other. You want to be able to manage these together, and then so these form this notion of an application model, and some additional things too, things like connections that these applications need. So think like different components need to talk to each other, or they need to talk to services that are available in the cloud environment where you're deploying the application. And then Verrazano also has this notion of an application binding, another YAML file that maps that application model to an environment. Includes things like placements. So I'm going to place particular applications in particular clusters. I'm going to set up the connections between these different components, and then possibly between different cloud services like a database or maybe a streaming service, set up an ingress. It also sets up I was going to say the network policies between these things. So this is, as you do these things, and it's all done through, kube control. You say kube control minus f apply, here's my model, kube control minus f apply, here's my binding. And then Verrazano interprets all of that and pushes it into the service mesh. And again, this service mesh is meant to be pretty locked down by default. There's, mutual TLS between the connections where there's connections are available, and then all other connections are denied. Verrazano also spins up or connects you to a monitoring stack, right? So, and again, this is, a set of things that you're probably built and trust, built into your environment and trust today. I think, Prometheus, Grafana, the Elastic Stack, and so forth. So pretty good stuff. And as we're getting into the details, I want to make sure we remember some of the value pieces here that, it is made up of open source components that you do trust. Verrazano handles the challenges of making sure everything works well together, right? Think curated stack, tested. The declarative model and binding files make it easy to deploy complex applications. The whole platform is set up to work with Kubernetes, DevOps, and GitOps. It fits into what you're already doing or planning to do. And of course, security is baked in. As Will alluded to earlier too, our plans are to push this to open source. We're actually actively, in the throes of doing that. So watch for some announcements to come in the very near future. All right, Will, I'm going to pass back to you. Thank you. Will, we can't hear you.
You're muted, Will.
I think he's still focused on, there we go.
There we go. Sorry about that. Managed to mess up my sharing. Thank you all for joining. Am I sharing my screen?
Yes.
Yes, sir.
Okay. Thank you all for joining and for staying with us throughout this presentation. If you've got your screen grab software, you can take a screenshot of this page. This is just a link to resources that you can use, link to our source code, link to examples, link to blogs on the overall new products we've introduced and some of the features, links to video, links to Slack channels to get help and get started. So we hope you are all interested in experimenting with these technologies and learning more about them, and reach out to us if you need help. And look for more news coming soon on Verrazano. Thank you all. We'll call it a wrap. See you next time. Bye-bye.